So I make a half past, so I'm going to make a start. If anybody else joins, I can always do a quick recap if there's anything that they've missed. But the important bits will be with both Kevin and Adeel, so they'll be the bits that you'll probably be most interested in. So first of all, thank you for joining our virtual open event. Obviously, it's not the same as having you in college and seeing our facilities and meeting our staff, and we would much prefer to do that. But just at the moment, this is all we can do. So hopefully you do find it useful. Hopefully you'll get everything, all the information today that you need to make your choice about next year. So I'm just going to start with a short presentation. It'll be no longer than 5 minutes, just to give you some general college information. Any questions that you've got, you can pop into the chat facility. So just a quick recap for those that have joined us in the past couple of minutes. Your camera and your mic will be switched off. The only people that will appear on screen at any point is myself, Kevin or Adeel, the staff from engineering. So any questions, use the Q&A or the chat facility. Okay, so first of all, welcome to St Helens College, welcome to our open event. Hopefully you'll find all the information useful today to make your decision for next year and where you're going to study and what you're going to study. So first of all, if you've not yet applied, you can do so on our website. So if you've not put your application in and you're just here today to hear a little bit more about our courses and what we offer at college, and you decide that you do want to apply, that's great. So you can apply on our website following the link at the bottom of the screen at the moment. We would recommend applying as soon as possible. That just gives you the chance to have your telephone interview and get all of our get your place secured for September. Obviously our places do fill up, so the sooner you apply, the better. So obviously you're here today to hear about engineering, but they are just a list of all the other courses that we do offer at college too. So if you're not yet made your mind up or you're not sure on what you want to study, or just general information there to see what else we do offer across our campuses. But obviously you are here today to hear all about engineering. So with engineering, although you will have applied for a full-time course, we do also offer apprenticeships. How an apprenticeship works is you would need an employer for your training. We can't always support you in finding that employer. So if you've got an employer in place, that's great. You contact us and we'll do the rest. If you've not got an employer and you are interested in an apprenticeship, you would need to start looking about now for vacancies and for an employer to take you on. Just a bit of information on apprenticeships. So it's a minimum of 30 hours a week. That's usually 4 days in the workplace and 1 day at college. So the day at college, you come into us and you do your training. That'll be your qualification at the end of it. How it's different to a full-time course. So obviously you spend the majority of your time in the workplace. So it is sort of like a full-time study, because you're doing your workplace and you're doing your day at college too. And the difference with that and the full-time course is that you're getting paid to do it. And you're also going to come out the other end with couple of years experience, hopefully a really good reference from your employer, potential for full-time employment at the end of it too. So that's just a little bit of information on how an apprenticeship works and how it differs from a full-time course at college. If you are interested in apprenticeships, you can always download a copy of our guide. So if you go onto our website, so sthelens.ac.uk/apprenticeships, you can get a copy of our guide. The link below where it's /job shop, that's a link to our current vacancies. So we don't always have vacancies within each area, so engineering for example, but if we do have any vacancies, that's where they're listed. So you can always look on there to keep up with our current vacancies too. So benefits of being a student at St Helens College. So all of our students benefit from a free breakfast. So if you're in college on time, so it's before 9:15, you will be entitled to a free breakfast to set you up for the day. All of our students get free transport too. So we do have a free college bus that covers places like Wigan, St Helens, Knowsley. And if you live in any of those areas and you're on our free college bus route, you can use our free bus. If you're not on one of those routes, you will be offered a free Arriva bus pass. So all of our students have got a free means of transport for college. You'll also get the free Microsoft Office 365 package that you can download on your computers or laptops at home. So that will support you with anything like coursework, keeping in touch with your tutors. If by chance any of our sessions end up being online, hopefully that should help you getting ready for preparing to start in September. Student discount, so it goes without saying, as a student you'll be entitled to discounts, so that's in places like the cinema, restaurants, clothes shops, that sort of thing. And then the bottom three, where you can see bursaries, free college lunch and assistance to buy course equipment and uniforms. So they're done off an independent financial assessment for each student. So you may be entitled to those, but not necessarily. That goes off each individual and their circumstances, but that's something that you may be entitled to, and that's all done at enrolment stage, so you'll know at the beginning of the year if you are entitled to that. Okay, so at college we have an excellent safeguarding and wellbeing team. They're on hand to support all of our students, whether that's something, whether it's something personal, whether it's something college related, whether it's something that you're stressed out about, anything along those lines. Our team are there to help you, and they work across all of our campuses. So there's always somebody that can support you or help you if you're struggling, or just need somebody to chat to. Obviously that's all done with confidence with our safeguarding and wellbeing team. We also have a learner support team. So if you have any additional learning needs, whether that's something like dyslexia or anything along those lines, where you may need some support in class, you may need extra time with your exams, anything like that, we can also get that support in place. You just need to be honest with us at enrolment, so we can get that sorted from the beginning of the year. And then finally, our social media pages. So we have a lot of students that go on to amazing things when they leave our college, and we put all of those success stories, we push them out through our social media channels. So if you go onto them, you might find a little bit of inspiration to see what past students are up to now and what they've gone on to. So there'll be, we do have some success stories from engineering apprentices, so you might get a little bit of inspiration by looking at those. And then at the bottom, you'll see our admissions email. So that is just there. We've put that there. If you've got any issues, if you've applied and you've changed your mind on your course, if you've got any questions about your application, anything anything you may be wondering, you can contact admissions and they'll be able to help you. That email's also there because at the moment our staff are contacting all applicants. So if you've applied for college but you've not yet had your interview, our staff will be contacting you within the next week or so. If you don't hear from us, I would say by the end of this week, so by Friday the 10th of July, if you've not heard from us for your interview, please contact our admissions team, because it may be that we've got wrong details for you on the system. It could be there was a typo when you've applied or anything like that. So it could be that we've tried contacting you and we've not got the right details. So if you don't hear from us, please get in touch. Okay, so that's the end of my presentation. I'm going to stop sharing my screen. I'm going to pass over to Kevin and Adeel. Like I mentioned at the beginning, any questions, pop them in the Q&A and chat, and once Kevin and Adeel have finished their presentation, I'll come back to those and we'll answer as many questions as we can. Okay, thanks.
Well, morning chaps, morning ladies. I'm going to share my screen, go straight into the presentation I've got ready for you, which I'm hoping works very well. Now, the focus today is going to be very much about electrical and electronic engineering. There's a separate presentation, virtual open afternoon at 3 o'clock for the mechanical side. I am, however, going to talk about the mechanical element of the electrical engineering course. Engineering is quite an interesting subject in that there's a base, if you will, of an engineering knowledge, which tends to be called mechanical. And then over the top, we have specialisms. In this case, it's electrical and electronic, and they very much tie together. Now, in the department, there are 4 main lecturers. 2 of us are online today. Adeel is online with us. There's Arthur, me, Kevin, and there's Khalid. And between us, I had to go adding up the numbers, but I ran out of fingers. It's more than 100 years experience that we're bringing to the college in business, in teaching, and in industry. And together we've brought together what we like to think is a very interesting and varied course that's designed to meet the needs of employers. This is very much a vocational approach. So, rather than me tell you what is engineering, let me play this video, which I think helps to show it in about 4 and a bit minutes or so.
What is engineering? Let's take a moment to think about your morning. The alarm on your phone goes off at 7:03. You drag yourself to the shower and blast yourself with perfectly warm water in an attempt to wake up. You smear your toothbrush with too much toothpaste and scrub yourself into a foamy mess of minty freshness. You're running late, so you skate downtown, weaving through the commuters, dart across the road, barely making the lights, and jump on the train just before the doors beep shut. There's a couple of stops to go, so you pull out your phone and play a few games of Angry Birds. Alarms, trains, traffic lights, video games, toothpaste, all these things were made possible by engineers. But what prompts an engineer to improve our world? Well, they solve problems. Problems are an engineer's inspiration, and maths and science are the creative tools they use to solve them. Problems like making your alarm go up at the right time, or making sure your toothpaste has just the right balance of chemicals to give you that perfect smile, or even making a game so addictive it's almost impossible to put down, if that really is a problem. Now let's head over to the airport and jump on an aeroplane. Aeroplanes. They're so easy to take for granted. But don't forget, you can fly. Before aeroplanes, flying was quite a bit more challenging. Every bit of your plane has been touched by engineers. A mechanical engineer designed the engine. A mechatronics engineer devised the controls. The fuel? Extracted by mining engineers and refined by chemical engineers. The navigation systems? Electrical and software engineers created those. Yeah, a whole team of engineers. Now we've landed in Dubai, home of the Burj Khalifa. It's the world's tallest building at 829.8 meters high. It's also in one of the world's hottest environments, reaching up to 50 degrees in summer. One of the difficulties of building the Burj was trying to figure out how to set 45,000 cubic meters of reinforced concrete in such extreme weather. The solution? A clever method of pumping iced liquid concrete into the 55,000-ton steel frame during the night. The result? A building that's vertically over 800 meters high, rather than horizontally all over the ground. Now let's jump into our time machine and go back to Saturday. Saturday, March 1932. The Sydney Harbour Bridge is about to open. The bridge is a marvel of civil engineering and a pretty cool place to set off some fireworks. Since 1815, people had been talking about building a bridge to connect the two sides of the harbour. The problem was that the harbour was so incredibly wide. How could a bridge span such a width and support its own weight? The solution? The Romans. Well, actually it was an idea they came up with. The arched bridge works by transferring the weight into horizontal forces and bracing them at the ends of the arch. But what about the future? What problems will engineers solve next? Will we finally have affordable solar power? Or robots that can perform life-saving surgery? Or a building that's so tall your view is of outer space? Or how about finally engineering a working hoverboard? Seriously, we've waited long enough. So what is engineering? It's solving problems. It's taking crazy, out there ideas and seeing if they're actually possible. And when they are, the idea is shared with the world to make all our lives better. So, what problems do you want to solve?
Now, thanks obviously to University of Newcastle in Australia for putting that video together. I think it summarises rather well what is engineering, and it touches on a number of the topics that we deal with. And there was a word in there, mechatronics, that you may or may not have heard of before. We're going to touch on that a bit later on. So, in electrical and electronic engineering, we're offering what? Well, we're learning how to design, build, control, and maintain machines, vehicles, and structures. Now that's a heck of a long sentence, I get that. We'll just ponder on that graphic for a moment, if you would. So designing something, what do you make it from? How strong does it need to be? How do you build something? How do you control it, which means how fast does it go? How far does it move? And then how do you maintain something? That's fundamentally what we plan on teaching you at St Helens College. So, a word of note. because we get this question quite a lot. Electrical engineering is not the same as electrical installation, which is also offered at St Helens. And if that's what you're interested in, it's a terrific course. On screen, what we've got is the installation lab that has the workshops and individual workstations where students are taught how to install consumer units, wiring sockets, lighting circuits, and so on. And if that's the bit that you're interested in, that's the electrical installation course, and you probably need to talk to those chaps about that. Electrical engineering is this build, control, maintain system that we were talking about before on the previous slide. So, we're based at the STEM Centre. You probably know that already, the Technology Centre for the St Helens College. Inside those modern buildings, nice classrooms, workshops, and offices. The library is nice and bright, as you can see on the images on there. Terrific workspace where there's printing and computing facilities and so on. So, electrical courses then. There are two levels that we're talking about. There's level 2, level 3, and we're also going to touch on the apprenticeships that Bethan already talked about initially. We'll start with level 2. So, what is a level 2 qualification? Well, it's equivalent to a GCSE, but focused. So I've called it GCSE Plus, and it's focused on our topic of engineering. We teach the principles of engineering and the principles of electronics. But there's a lot of practical hands-on work as well. Ultimately, if you pass the course, you get awarded a technical certificate in engineering, awarded by City and Guilds. So what do you need to get on the course? Well, you need 4 grade 3 or equivalent GCSEs, and we do need that to be in English and Maths grade 3 or above. Ideally, we want grade 4s, so that's not a problem. If you just get your grade 3, not a worry at all, because we'll automatically enroll you onto English and Maths to support that side of the course. That's free of charge. That's all offered as part of your engineering course. A level 3 course is a little bit higher again, and that's an equivalent to A-levels. And we teach there the principles, again, of engineering, of the principles of electrical and electronics engineering. So the syllabus is broadening out, and it's going in much more depth as well. That's supported by a lot of practical hands-on work. And again, the qualification that's awarded could either be a technical certificate or a technical diploma in engineering, and that's awarded by City and Guilds. You may be wondering, what's the difference? Well, a certificate takes 1 year and the diploma takes 2. Okay, so what do you need to get on the course? A little bit higher this time. We now need 4 GCSEs. They need to be at grade 3 or above. But this time your English, Maths and Science need to be at grade 4. If you also are thinking, well, I'd quite like to get onto the university pathway, and that would mean completing the level 3 at diploma level and then moving on to a level 4, which is HNC. Well, we have that university pathway as indicated here on the slide. And there we offer this subject called Core Maths, which is an additional maths subject. And to take that, you would need a grade 5 or 6, or the old B for old people like me. You need a grade 5 or 6 in Maths and Science. So there's a pathway there for everybody. Either you join us at level 2 and progress all the way through level 3, or you can come straight in at level 3 if you've got the higher grades already. All right. Now, how do we decide between certificate or diploma? Well, that's determined by your grades and your interview. So students with English and Maths at grade 4 or above, and you believe you've got the attributes to finish the course, that's great. That's the certificate, that's the 1-year course. Those with higher qualifications, grades 5 and above, we'd be looking to invite you onto the diploma for 2 years. Highly recommended to go for that if you've got the grades to cope with it. If you haven't, it doesn't matter. because you can join us for the certificate for the first year, and if you do well on that, you can then apply to join the diploma. 1 year follows the next. Okay, so what will you learn? Each year, students will study 40% theory and 60% practical. So there's a lot of hands-on work. And that's because we have worked very closely with the employers via the apprenticeship program that we teach on. They want us to provide them with students with the practical skills. They need to know the theory, but they need the practical skills as well. So the theory covers your special path: electrical engineering, electronic engineering, mechatronics, mechanical engineering, your special path, but also some general engineering units. I'm going to talk a little bit about the general engineering a bit later on. There's practical work, which, for example, would be a project. And in that large project, towards the end of the teaching, you'd be combining all of your theory knowledge with your practical skills to produce one working product. An example recently is an automatic barrier that rises and lowers, similar to a car park barrier. So it needs sensors to detect when a vehicle is present and when the vehicle has passed, and all that sort of work. And that involves a whole combination of theory and practical work. You will also be enrolled on English and Maths GCSEs if you've not got your level 4s. So that would be for the grade 4, at GCSE. So assessments, everyone needs to know this. How do we know how you're getting on? Well, it depends on which unit. And each unit is just which part of the course. Some units are examined at the end of the year, and some are assessed throughout the year. So we give you projects to complete. And an increasing number of units are now have a mixture of both exam at the end and assessments throughout the year. And that we find is quite a useful way of assessing where you are, how we can teach you better, and how you can improve on your own skills. So, going to have two nice rotating cogs on screen for this, because I want to talk to you about two separate workshops. There's many different workshops in STEM. The main workshop we're going to talk to you about is the electrical workshop, but we're also going to touch on the mechanical side, because in the mechanical workshop, that's this core of engineering, and the electrical is where your specialism lies over the top, and we mesh those two together, rather similar to this gear that's moving around. So we'll start with the electrical lab. So the electrical workshops have had significant investment, and that's been ongoing at the moment. So I can't share with you up-to-date photos because we can't get into college at the moment with lockdown. What I can do is show you a plan view instead. It's not to scale, but hopefully you get the idea. So if you're looking above, looking down on the floor, we've got a rectangular shape, and in there we've got a number of workbenches where you're doing the practical work. There's some storage for student work as they progress through, and we'll show that in a moment. There's a teaching monitor where we can deliver some of the classes. There's a couple of whiteboards, and our new area, this design and development area. And that photo shows the work partway through. The wall at the back over here is now fully plastered, and this whiteboard is now in place with these desks, so we can deliver classes directly on the theory topics, and then you get straight into the practical to practice it. So there are four main areas that you need to think about when we go, well, what do we teach you? So if we look at power engineering, which is looking at national grid, power distribution and generation, whether it's burning fuels or by solar or other forms of renewables. And you end up with competent engineers wearing the correct PPE, able to read technical drawings to interpret what's going on inside this cabinet to check that this is functioning correctly. Second topic is electronics. This is where you're looking at very small items, very small voltages, tiny little pieces of microelectronics. And we start you off with this item here, this white item, which we'd call a breadboard. And you can plug little pieces into that breadboard. You get taught those skills. So the theory would be the design of the circuit. The practical would then be to take those pieces and plug them into a breadboard, connect them up and test, as this individual is showing here, using these test probes and a multimeter. Does the circuit work? You then progress on to more complex circuits and how to solder without damaging the circuit, for example. And then there's a project. Now this year the project was to design and make an audio amplifier powered by batteries, delivering a signal from your mobile phone that can play music through a loudspeaker. A really nice little project. We then move on to control engineering. Now, this is a stock photo because the actual photos I haven't got in front of me, unfortunately, because the labs are closed at the moment. But this shows a conveyor belt and it runs from right to left. There's a stop-start button and all sorts of electronics. And this is the key piece of electronics that we teach. It's called a programmable logic controller. And it might sound awfully complicated, but what we can get this machine to do is to start the conveyor slowly so it doesn't throw the parts off it, stop it slowly, and also by having some sensors along there and some pushers, items can be split into these bins. So we teach you the basics of control engineering, and that then progresses. And these two photographs show actual student work. This is at the end of a level 3. In the background, you can see some circuits that also have a programmable logic controller and various switches. And because they're open, they're quite easy to get in. And you learn the techniques of how to wire and do the cabling. And you then progress to make these control boxes. And this is the inside of the box. And there's the programmable logic controller and various other electronic components inside. And that'll be a project that you do if you join us on the diploma. Quite an advanced piece of engineering. And these are used every day in industry. Fourth topic that we're moving on to is mechatronics. Here's an example of something that's a mechatronic device, a pick and place robot. So it's a mechanical device, and this is where the base mechanical engineering comes in, combined with the electrical and electronic control to program and then control that robot. A second example is some side panels being placed on the Tesla Model S from their factory out in California. Those robots needed to be designed by mechatronic engineers, and that's a topic that we're really getting into at the moment and our employers are asking for. Some of the investment that's been going on in the electrical department has allowed us to buy some equipment from a company called Festo. They're a global corporation who manufacture industrial automation systems, but also some teaching systems like the example you can see on screen. And that allows us to teach the application of mechatronics and control engineering. And the example on screen shows a conveyor belt, pieces that can be loaded into this track, a pick and place robot over here, and various other components that can be moved around the board. That, with the best students, allows us to enter the mechatronics competition of World Skills UK. Quite a prestigious competition to go for. It's a modular production system, which means those parts on that board we can move around. We've got a 2-station setup that can do parts dispensing, assembly, and parts sorting based on size and color and shape of material. And it mimics, this is the key thing, it mimics a production line, scaled down, using industrial components, using the same industrial language as used in industry, but it's designed for teaching purposes. Another layout of the same equipment is shown here, where we've got 4 processes where we can measure fluids, the level, the flow rate, the temperature and pressure. And combined with the mechanical system that you can see on screen here, with 2 conveyors this time and a sorting tray. You see these paddles over here? Well, they can be programmed for items that pass along to go into each of these 3 channels. There's also what's called an and-on light. You're familiar with these from the supermarket. A green light would say, yep, the machine's okay. The orange light can be programmed. Things are starting to move out of shape. Something's not right. Can I have an engineer to come and fix it? And the red light, of course, is it stopped working. Between all of these different modular components allows us to teach the full spectrum of control engineering, which is relevant to a wide range of industrial processes. So control engineering then allows us engineers to control machines accurately, repeatedly, with precision, and vary from slow control to fast response, depending on what we require. And we can then enter the other side of the competition, which is the industrial control competition of WorldSkills UK. And it's something that we're really targeting this year. So we've talked about this base end of knowledge of mechanical engineering combined with the specialism of electrical and electronics. So in year one, we always cover this base engineering, which is used throughout civil engineering and mechanical. So I've drawn on screen the mechanical side as well. I'm going to talk to you a little bit about the mechanical side. So what is mechanical engineering? Well, design, and typically design is done with proper engineering drawings. This 3D part up here, a hub, is drawn in a specific way that engineers are taught, and we all understand around the entire world. We all draw them exactly the same way. Nowadays, we use computer-aided design to allow us to draw the 3D shape. And here's the rotor from electric motor. And to draw that, there's various different components on there, and they're made of different materials. So we teach that as well. There's four main categories of material. You've got metals, plastics, ceramics, and composites. And in this drawing, there's steel and there's copper wire, and there'd be a plastic, a polymer impeller for this pump. Well, why do we choose those materials? And some of that comes down to their strength. How much do they bend? Are they stiffer in a different angle? How strong are they in tension or compression? Which then moves on to even more investment that we've had at STEM Centre, where we're looking at something called CAD/CAM. And that's computer-aided design and manufacturing. And the example shown here is from the dentist world, where a scan can be taken of somebody's mouth to allow a model to be created in 3D and sent to a 3D printer to produce a 3D model of someone's teeth to enable implants and what have you to be made specific to that client. So we talked a little bit about some of our workshops. I think it's important to stress that no matter what, health and safety is a priority. For example, students are only allowed in our workshops when they're wearing the correct PPE. That's the same as you'll see in every single place of work. We supply the overalls and the boots, as you can see, a safe place to put your personal possessions. And at the moment, there are builders in the workshops improving the changing and wash stations, so everything is all sparkly and brand new from September. It's going to be a pretty super workshop. Several £100,000 have been spent in there from a grant that's been awarded recently. And of course, eyewear and ear protection are always provided for whichever activity you're doing. Now, the mechanical workshops, these are stock images from the past, but these are our workshops. And you can see here one of our lecturers showing a student how to use a hacksaw. And then we've got a few more examples of students using some of the machinery. This case is a student working on a lathe. And again, face of concentration, which is always good to see. Working on a milling machine. So in this case, the workpiece is held in these jaws, and this head is spinning vertically to cut the piece. He's not staring into space, he's actually looking at the control panel above the machine. And here we've got a student learning how to use a grinder, and another student showing a lathe in action. And all of these skills form the fundamental base of what makes an engineer solving problems, able to fix things. So I talked about new investment, and one of the biggest investments has gone into the mechanical workshops, and they've installed brand new machinery. And I talked before about the CAD, the computer-aided design that allows us to produce a complex 3D shape like this gold-coloured part on screen. Well, that can be then sent using a specific type of file, an example of screenshot you can see here, where we program the machine and send it down electronically to a computer-aided manufacturing machine to make that part. Now, these are stock images because that equipment is still in its wrappers and being commissioned over the next month or so. We also do educational trips, and this year we went to Jaguar Land Rover. They make the Freelander, no, what is that one? That's the Discovery Sport and the Evoque are both made down at the Halewood Operations Centre, and all students get a tremendous amount out of these visits. For example, the opportunity to see flat sheets of steel turned into fully working, functioning cars. It's quite an opportunity. Now, we touched on apprenticeships, and on screen I'm showing you some of the brands of companies where we've currently got apprentices working. The NHS, of course, we're rather familiar with that. Cal International is a local, they're based in Knowsley, design consultancy. Bryken Precision Engineers make ball bearings and other very high precision items. Companies like Food Pack, they pack high precision, fast moving goods. And one of the brands that you may know of that's familiar with Food Pack, and another company we work with called Greencore, would be a pot noodle. So those plastic pots need to be handled, they need to be measured, they need to be correctly filled to the correct weight, they need to be sealed, and all of that machinery, that's where we come in. We got apprentices at John Moores University, Tate, Security and Fire Alarm Systems, CBRE, you may not have heard of that brand, but they are an enormous corporation that own thousands of properties around the world who need engineers to look after them. SemCorp are part of National Grid, and we've got apprentices in the Jaguar Land Rover site as well, just to give you some examples. Now, as Bethan said before, the place to go is this website. What I can tell you about is what we do as tutors. So, what do we do? Well, first thing we talk about is an apprenticeship is a job. So that's a job to be applied for. What we do is the teaching. Now, within St Helens College, we also have a company called Waterside, and they offer apprentices too. So there's the second website to look at. And as Bethan said, go to those websites. We don't do that for you. This is a job, your job. You need to apply for it. And the advice I've got on this screen comes from our team at St Helens Apprenticeships website link. Angela is the lady to talk to, supremely knowledgeable on her topic. And there's two different ways that we do the apprenticeships. In college, we do a day release program. In Waterside, they start their first year full time and then move on to day release. College apprentices are day release. And on screen, I've just drawn a couple of arrows here. Our links with industry, with our own apprentices, and our links with Waterside and their apprentices mean that the courses we design are specifically targeting what those companies require. And a question we often get from students and parents and other people is, can students transfer from their full-time education to an apprenticeship? And the answer is absolutely, because we design our courses to meet the needs of industry and our sister company, Waterside. So, apprenticeships need to be applied for. They are a job. So the employer needs to interview, as well as you meeting college entry requirements I went through before. You need to have a place on a study program, even if it's your backup plan. Apprenticeships are only secure once you've got an offer of employment, they've signed a contract with an employer, and you've got a place on the study program. Now that's the important point. start with getting yourself on the study program. Our engineering courses are very popular and we always fill up. First come, first served, get your grades, get enrolled. That's your first step. Hopefully that explains a little bit about that, but the place to go are these two websites that we've got indicated up here on the screen. So, hopefully, now we've got some sort of introduction to mechanical electrical engineering and what we do. I'll just switch the machine on. And if you've got any questions, myself and Adeel will be happy to help.
Fab.
I would like to, sorry Beth, just 1 minute. I won't be long. I would like to thank you to all of you for joining us on this webinar. And I can see like maybe confusion between mechanical and electrical. We are the same department and we deal with, I am the curriculum leader for both electrical and mechanical. And if you have any questions regarding both electrical and mechanical, you can always email me and Kevin directly. And I wish you all the best and I'd like to see you soon. I'll pass it to Beth now. Thank you, Beth.
Brilliant, thank you.
Thanks,
So,
Kevin, again.
if you'd like to, in the chat facility and on the screen, if you've got any questions or in the Q&A, now is your time to pop them in. Kevin, Adeel, I don't know whether you want to both pop your email addresses in the chat box. That's what some of the staff have done that in the other sessions, just so that the people who've attended today have got your contact details. So like I said, I'll give you a couple of minutes now. If you've got any questions, you can pop them in. What will happen after this session, you'll get an email thanking you for attending and with just a little bit of information on. So there will be contact details on there as well. So if there's something that you think later on you wish you would have asked, you can always send the questions in, so don't worry too much. But if there is any questions, now is your time to send them in. Adeel and Kevin are both going to share their contact details with you as well in the chat, so you can always save those, do a screenshot or something if you're on your phone. Yeah. There doesn't seem to be any questions coming in, but I think you've been quite thorough there. So you've gone through electrical, you've gone through mechanical, quite a lot of information, pictures of the workshops, that sort of thing. I don't know whether, nobody has asked this, but I don't know whether you just want to touch on uniform at all, Kevin. I know you did mention about like PPE and things like that. Do the students have to order their uniforms, and how do they do that?
Yeah, typically what we're trying to establish is how would you get a job. So people can wear their own clothes, and I'm wearing some fairly casual clothes today. Generally, if I'm in the office, I'd be wearing a more formal shirt, typical to what you'd see in industry. So that's the kind of environment we're trying to create. The overalls and the safety shoes are an absolute requirement. That's not a debate, and they're provided by the college. But we also have some polo shirts that are sold as well. I can't remember how much they cost, but they're pretty good value, and they're certainly very popular. Those are items that are ordered and delivered according to your size once you've got your enrolment confirmed.
Brilliant. I know that if it's anything similar to construction, earlier on they said that their polo tops are, I think they said about £15 for two. So I'm not sure whether
that sounds familiar.
Yeah, so that could be the same. And then we've had a question, will we have to wear a face mask and gloves when we start back? And I'm assuming that this is going to be following government guidelines, but that could be general PPE in the workshop anyway. I'm not sure if you want to...
Yeah, that is correct actually. So whatever the government guideline will be by the start date in September, then we will just follow that rule. But I mean, whenever we are in engineering workshops, we do wear almost everything apart from masks. But in the mechanical workshop, sometime if we are cutting or doing something, then we do wear that as well. But in electrical workshop, mostly we don't. But if this is the case, yes, we will be providing everything. And like Kevin mentioned regarding the workshop uniform, I think we do provide one set, to free to all students, and just they all only need to pay for the polo shirts basically, and it's £15 for two. That's it.
So overalls and protective shoes and things like that.
It'll be free. Yeah, the part of the course. Yeah.
Brilliant, because there's a couple of questions come in. How do we order uniform? Is there a website? That's all done at enrolment anyway.
We do it,
so,
yeah.
Yes, information on ordering uniform will be given at enrolment stage, so don't worry too much about that at the moment.
Yeah, whenever you guys walk in for the enrollment, and we will have the team there, they will take your sizes for your shoes and your overalls. And in the next week, we deliver, whenever you go in workshop, you will be fully ready and equipped with all the overalls, basically. Yeah, okay. So we will do that for you.
Fab, okay. So any other questions? You've got a couple of seconds now to get them in. Hopefully everything has been covered for you there. So we will just give it a few seconds, see if anything else comes in. No. Okay, so that looks like that's a wrap then. So thank you all so much for joining. Hopefully you found it really useful. I know there's been a lot of information to take in today from Kevin and Adeel, but hopefully we're trying to cover everything that you will get if you come to us and actually visited our workshop. So hopefully you found it really useful. Any questions? Kevin and Adeel have both popped their email addresses in the chat, so you can just take a copy of that, screenshot it on your phone, anything. If you've got any questions, just pop them over to Kevin or Adeel. I'll pop our admissions email into there too. If you've got any questions on your application or anything you want to check up, or if you want to swap your course, anything, contact admissions. That's in the chat now. There's a final question. How many days are we in college?
Yeah, minimum 3 days for your, even if you're on level 2 or level 3, for a full time, you have to be there for 3 days. And like Kevin mentioned in the PowerPoint, if someone is going for the university pathway, then he needs to be in for 4th day, like a half day for 4th day, because we do provide them extra maths and some extra science.
Okay, brilliant. And then there's just one more question come in, but we have answered that, so I'll just answer that now. So how do you order uniforms? Is it website or email? So no, it's when you come in for enrolment, you'll be given more information on that. So we usually have the uniform company out measuring and things like that, so you can order that way. Obviously, we're not sure what will happen with social distancing and things like that. We are hoping to have some of our enrolments in college, but it could be that they're online. We're just not entirely sure yet. But as soon as we know information on enrolment, you will know information. So as soon as our enrolment is confirmed, you'll get communications going out. So emails, usually texts and stuff like that as well. Probably won't get anything in the post because obviously there's no team working in college at the moment, so it will be done by email. But as soon as we know, you will know, and enrolment is usually the place where you order, so don't worry too much about your uniform or anything at the moment. I had a letter from St Helens College saying I've been accepted on electrical. Do you still need to enrol? Yes, Michael, you will still need to enrol. Enrolment starts on the 20th of August, so that's GCSE results day, and you will need to enrol. Even if you have had your place confirmed and you've had your interview and everything, you've got your place, that's fine, but you'll need to enrol, where we need, everybody has to do that, so we get all your details onto the system, enrolled onto your course, and that's when you'll start to order uniforms and things like that. Do we do both mechanical and electrical in our first year?
That's correct, yeah. For the first year, level 3, if you qualify for level 3, then you will be doing both electrical and mechanical course. It will be a balance between them. But in the second year, you will be doing a specific pathway. For example, if you are enrolling for electrical engineering, second year will be mostly focused on electrical engineering.
Okay, brilliant. So that's everything. No more questions have come in. Everything's been answered. So thank you all so much for joining. Hopefully you found it really useful. All that's left for us to say really is good luck with your GCSEs in August. And we look forward to welcoming you in September. So thank you all so much. Thank you, Adeel, and thank you, Kevin. That was really
Thank you, everybody.
Thank you, everybody.
Thanks, everyone. Thank you.
Thanks.
Bye.
Bye.